Hi everyone, in this example we're looking at the graphs of piecewise functions. So a piecewise function is simply a function that is made up of two different graphs across two different domains. And basically you just graph one at a time. So let's start with this top one here, and that works for when x is bigger than 2. So 2x plus 3 would be starting at 3 and going up 2 across 1, and that pattern would follow down as well. And we'd rule that in with the ruler, and that would be our graph. Now, our condition says that x has to be smaller than 2, and so in fact this graph would go all the way up to this point. But when we get past that point, we get to this graph here, which says x minus 6. So that means that it has an x-intercept at 6, and it's coming down 1 across 1, down 1 across 1, like this. Okay, now that graph starts to come into effect once it's bigger than or equal than 2, and so I'll just sketch it in, and then I'll talk about what that means. So it keeps on going in that direction. So basically, when we come to look at that condition, because x has to be bigger than or equal to 2, hang on, I just need to fix up my rubber here. Okay, now what I was saying is because x has to be bigger than or equal than 2, then actually we're not counting the graph at any point before then, so we can in fact rub it out. But there is a point at 2. Whereas our other graph, it says strictly less than 2, so that means that at 2 it doesn't exist. So to show that, we put a little open circle at that point there to show that that one doesn't exist, but this one does exist at that point. Okay, and that's piecewise graphs. So just two separate graphs that we draw across different domains, and that's all there is to it really. Okay, so you've got quite a few exercises to have a look at there, and I'll let you get on with those.